Okay, now we're going to look at how to draw polyatomic ions. It's a bit of a mouthful, but polyatomic ions are merely ions or collections of atoms or groups of atoms with a charge. And so when we start counting up electrons to draw these, we need to take charges into account. And I have a few examples here. We're going to start with nitrate right here. So if we look at this, we get 5 electrons from nitrogen, 6 from each oxygen, which gives us 18. But then the charge is -1, and when something has a -1 charge, that means we add an electron. So our grand total, or our total number of electrons here, are 24, all right? If we look at sulfate, we get 6 from sulfur, 24 from the 4 oxygens, and then +2 from the -2 here, and we end up with 32 electrons. Everybody get the idea so far? I'm gonna do it really well. For ammonia, we'll talk through it again, then I'll do it real fast for the others. So for ammonia, we get 5 from nitrogen, 4 from each hydrogen. But when something has a +1 charge, that means it's lost an electron. And so here, this compound has lost a single electron. So if we add this up, we get 8. For the azide ion, which is an interesting compound, this is what's in airbags, we get 3 times 5 is 15. Plus this negative charge, or the -1 charge, gives us 16 electrons. And finally, for the acetate ion, we get 4 plus 3 plus 4 plus 6 plus 6 plus 1 gives us, well, let's add this up, 7, 11, 17, 23, we get 24 electrons. Hopefully those examples will help you out, and in the next video we're going to draw all 5 of these. But before we get to that, we need to talk about something called resonance, all right? Resonance is something that plays a huge role in chemistry, especially organic chemistry. What it is the ability of double or triple bonds to move, all right? And this provides a huge stabilizing force for molecules, because if those double and triple bonds can move around, what that'll do is strengthen the bond between different atoms. And we're going to show you resonance, I'll show you resonance, as we move into these compounds. In particular, we're going to look at, well, actually all of them except for ammonia, you'll see some resonance structures.